Okay, today I will discuss about Cyrus Beck algorithm. Now, Cyrus Beck algorithm is quite tough with respect to the other algorithms we have learned so far. Now, before I discuss Cyrus Beck algorithm, I need to recapitulate few things regarding straight line, parametric equation, vector algebra, etc. So this is Cyrus Beck algorithm part 1, and in the part 2 I will discuss the entire algorithm. So first আমরা কিছু জিনিস recap করি, that is first thing হচ্ছে what is parametric line equation. Now আমরা জানি যে general line equation is y equals to mx plus c, but there is another concept we use, that is parametric equation. Now in terms of parametric equation, a line can be represented like that: pt is equals to p1 plus p2 minus p1 into t, where t lies between 0 to 1. So this is the equation of line in parametric representation. Now what is t, what is p1, what is p2? So p1 is the initial point from which the line is starting, and p2 is the ending point. Here if we consider the first point as x1 y1 and p2 is x2 y2, so we can represent x and y in the same equation as 1. Now what is the meaning? Now t is a parameter. T has got the value from 0 to 1. So if I put t0, that is t equals to 0, then the equation becomes p1 plus p2 minus p1 into 0, which means it is nothing but p1. So that is the initial point. Now if I consider p at t equals to 1, what is the value of p? I'll get p1 equals to p1 plus p2 minus p1 into 1. So after cancellation it will becomes p2. So it is quite simple to see that when the value of t is 0, it gives the first point, and when the value of t is 1, it gives the second point. So what is the meaning of that? The meaning is that by changing the value of t from 0 to 1, that is t may get the value like 0.1, 0.2, 0.3, 0.4, etc. up to 1, will get all the in-between points within the line. তার মানে যদি আমি p1 থেকে p2 অবধি কনসিডার করি যে when I am giving the value t equals to 0, I am getting the first point. When I am giving the value t equals to 1, I am getting the last point. If t equals to 0.5, I will get the middle point. If t equals to 0.25, I will get the point that is 1/4 distant away. So by varying the value of t, this is the parameter I can get the different values of different points within the line. So by changing t continuously, we can get different points on the same line. So starting from 0 to 1, with changing the value of t, I am generating a number of points. So I am generally use a concept like this is the regulator and this is the value 0, and if I clockwise, if I rotate the regulator, it will gradually goes from 0 to 1 through the different t values. তাহলে প্রত্যেকটা t ভ্যালু ক্রস করতে করতে গিয়ে ও 0 থেকে 1 এ যায়, and if the accordingly the line is generated. The different points from where the regulator is 0, it is the first point, then it is point 1, it is the second point, point 2, point 3, point 4, like that I'll get the first point to last point using varying the value of t. So it is very simple to write pt, or it is better to write p within bracket t is equals to p1 plus p2 minus p1 into t. Now if I want to represent xt and yt, so this is also same. Xt will be equals to x1 plus x2 minus x1 into t, and yt is also same. x1 plus y1 plus y2 minus y1 into t, when pt is represented by two dimension x and y. So this is the parametric line equation. Now it is very clear, since t is going from 0 to 1, I am getting a line from 0, that is left to right. So direction of the line is like that. If I draw the line from 1 to 0 or 0 to minus 1, whatever, I will get the negative direction. So when it is 0 to 1, we will get the line from left towards the right. So for that reason, we can consider any line like a vector going from first point P1 to last point P2. Now next thing that I have to discuss, so it is all about parametric line equation. Now the next thing is that this is vector algebra. So vector, few things I have to recapitulate. First thing is that what is cross product and what is dot product. So first of all, before that, I just represent any vector. Any vector can be represented in two-dimensional space by using a sign p cap or whatever. This is the notation of a vector. Now the modulus of a vector can be represented as p within modular operator, magnitude of the vector. So magnitude with the direction unit vector, I will get a point. So if a vector in two-dimensional space is represented by AB, then we call A is the position vector and B is another position vector. Now if this is the origin, so position vector is the vector from the origin to the point A, and position vector B will be the like that. So AB can be considered, vector AB is considered as OB, we can call it O, OB minus OA. So how it is forming? Using triangle law. So vector triangle law is like that. If I consider this is the first vector, this is the second vector, and this is the resultant vector, then triangle law says OA plus AB is equals to OB. OA plus AB in the same direction, and OA plus AB is in the same direction, and OB is the opposite direction. So after addition of these two, I'll get OB. So AB will be, from this equation you can get AB is equals to OB minus OA. This is the same equation. So difference of OB minus OA. So in short, if I represent any vector that is PQ like that, then PQ will be OP minus OQ, or sorry, OQ minus OP. So from Q to P we have to subtract. So PQ will be OQ minus OP. Okay. Now I am considering the point as position vector as Q and the vector as P. So I can also write Q minus P is PQ, considering the coordinate of Q and coordinate of P. So now this is vector representation. Now what is dot product? Now dot product, there are two types of product. One is dot product and another one is cross product. Now if there is a vector AB, then AB cos theta is the projection on x-axis. So this is AB cos theta. And if there is another vector that is represented by the red line on the same x-axis, suppose this is AC, then AC into AB or AB into AC, that is the dot product of AB and AC, will be AC into AB cos theta. So this will give the dot product of AB and AC. So we have to draw a projection on the line. So if this is a vector V, this is a vector X, then I have to drop a projection of X on V, on the direction of V, and then multiply it. So projection of X, if this is theta, then X cos theta is the projection into V, will give the dot product of X and V, or we can call it XV cos theta, or that is AC into AB cos theta in magnitude, in terms of magnitude. And dot product is always scalar, that is, it has no direction, it has only magnitude. We know that force and displacement are not cross product, they are dot product. So this is, I can call it, this is dot. So this will give the work. Work is a scalar quantity. So after any dot product we will get a scalar value. Now suppose there is a point P1, this is a vector, it has got value x1i plus y1j. This is the representation of a point in vector with coordinates x1 and y1. So I is the unit vector along x-axis and j is the unit vector along y-axis. So P1 is represented by x1 and y1. So this j is P1 with coordinates x1, y1, and here is unit vectors I, and this is suppose j. Now P1 is x1 plus y1j, and suppose Q1 is equals to, okay, this is, let's call it P2. P2 equals to x2i plus y2j. Then if I make a vector product of P1 dot product of P1 in P2, so P1 dot P2 will be x1 I plus y1j dot x2i dot x2i plus y2j. Now we know that cos value, that is if the angle between two vectors is 90 degree, then cos 90 is 0. So if two vectors have got 90 degree apart, then the multiplication will be resulted in 0 because cos 90 is 0. Now I, and if I multiply these two, x1 into x2, I will get x1 x2. Now I into I is nothing but I, and it will cancel, I dot I. So it is cos 0 is 1. Okay, so cos 0 is 1. So if the multiplication of x1 into x2 into cos theta, theta is 0, so cos 0 will become 1, and I will get only x1 and x2. So after multiplication I am getting x1, x2. Then I multiply with x1, y2. Now what will happen? This will give x1, y2 and I dot j. And I and j, the angle between I and j is 90 degree. So cos 90, I into j cos 90 degree, this cos 90 will be 0. And if this is 0, the entire term will be 0. So this will become 0. So I will get x1, x2, and then this term also becomes 0 because j into I. So what remains? x1, x2 plus y1, y2. So result is x1, x2 plus y1, y2. Other two terms will become 0. So this is dot product. I am not discussing about cross product right now because it is not required here. So So this is about dot product, and now I'll discuss about Cyrus Beck algorithm initial steps. So in this algorithm we are considering a clipping window. Like that. Oh shit. So it is quite squarish clipping window. Now there is a line which is going from this direction, from the outside to the inside of the clipping window. So the direction of the line is this. The initial point is P1, the final point is P2. And we consider a corner point which lies on the clipping window is Q. Okay. So P1 and P2 are the initial and final point. Q is a corner point. I have taken it at the top left corner of the window. It may be at any point, but I am considering it like here. So if in this case, what is the initial point P1 in terms of parametric equation? It is P0. That is at t equals to 0, the point is P1. And what is about P2? P2 is P1. When the t value is 1, it is the last point. Now we consider any point on the line, any point. It may be here or here or here. Its value is given by with some t value pt, with some t value maybe t equals to 0.24, 0.3, 0.5, 0.7, whatever. So we, according to that value, it will produce some point. So pt is a point on the line at some t value. Okay. Now I am drawing a vector from the point Q to the line at PT. So I am dropping a vector from Q to PT. So the vector can be represented, this which I have dropped just right now can be represented as PT minus Q, as I have told earlier that any vector PQ is represented by Q minus P. So PT is the vector, point vector, and Q is another point vector, position vector. So PT minus Q is the, say, vector X. The name of the vector is X. So X equals to PT minus Q, I can call it. Okay. Now, Cyrus Beck considers unit vector on each of the window. So, he considers a unit vector perpendicular to the window boundary. So, this is an unit vector. What is a unit vector? Unit vector has got magnitude 1. একটা যে কোনো unit vector আমি যদি consider করি, তার magnitude of 1, it has got only direction. So left window যেটা আছে তার উপর যদি unit vector consider করি, that will be like that, perpendicular to the left boundary. And I consider on the bottom window, bottom edge of the window, I'll get the vector like that. If I consider right. So every unit vector is towards the interior. So every unit vector which I am considering are directed towards the interior of the window. So these are the 4 unit vectors. This is a square, this is maybe a rectangle. Everywhere it may be a pentagon. Everywhere we have to consider the perpendicular vector with the corresponding edge. So I have considered these unit vectors along every edge. Now this vector pt minus q, this one x, I am gradually going towards the interior of the window. So from here to here I am gradually going inside along the line with different values of pt. Changing the t, I am getting new point and I am connecting q with that new point. This way. So after, when it comes along the window, suppose this is the vector. No, the line is good. So I am taking this blue line. So it is the vector from q to pt which is along the edge, left edge. At this point, pt minus q will give this vector x. And what is the unit vector? Unit vector is this one in purple. Now if I take a dot product with these two vectors, what will happen? So I am taking this picture here. So suppose this is my q and this is pt, and here the perpendicular vector, that is normal unit vector, is this. I can call it n. Okay. Then if I place these two vectors end to end and make a dot product. Okay, this is small n. Better to take it small n. So every unit vector, this vector is taken as small n. Now if I take the dot product of these two, what will happen? The angle between these two vectors n and pt minus q is 90 degree. So I can write it pt minus q into n cos theta, and this theta is 90 degree, so it will become cos 0 and this entire term will become equals to 0. So the boundary condition when the vector x aligns with the left edge, it has got 90 degree angle with the unit vector which I have drawn perpendicular to the edge. So the symbol of unit vector is like that. So this is my boundary condition, pt minus q dot n equals to 0. Now what is pt? What is pt? I have already discussed. pt P1 plus P2 minus P1 into T. So I am writing the value. Pt is equals to P1. Pt, the line is starting from P1 ending at P2. So Pt can be written as P1 plus P2 minus P1 into T. Okay, so P1 is also initial point, P2 minus P1 is also initial point. I can represent it like that, into T minus Q vector dot n equals to 0 is the boundary condition when it holds, when the vector Pt minus Q aligns with left edge. This is the boundary condition. Now I can separate out these two things as P1 minus Q into N and P2 minus P1 into T into N. This is a simple multiplication. This is not dot product. This is P1, this is P2. P2 minus P1 into T into N equals to 0. Now P2 minus P1 is the vector from P1 to P2. That is the direction of the line, P2 minus P1. And P1 minus Q is something else. Okay, so I will discuss the entire thing later on. This is the end of first part of Cyrus Beck. So I am going towards the Cyrus Beck algorithm slowly.